Welcome back. We're going to look at a specific case of reaction, and that's called ozonolysis. So in which, depending on what is added with the ozone itself can determine the type of products you make. Okay, in this case, we're going to take an alkene and make aldehyde and ketone out of it. And to do that, well, don't worry too much. I'll give you a random alkene, okay? And I give you this. This is ozone. Okay, if you ever wondered what ozone's formula is, well, now you know. This is ozone. This is dimethyl sulfide, or also known as DMS. That's dimethyl sulfide. Okay. So if this is the reagent, this is the reaction condition, and these are the reagents, then again, first what I want you to do is, given an alkene, obviously I would be very cautious on what I give you. This contains a hydrogen, right? These are the two carbon, it contains the double bond. That's where our interest is. And one of them is clearly containing the hydrogen. So what we need to do is the carbon that contains hydrogen and anything to the left of it, okay, we draw this and draw a double bond O and a hydrogen. Keep everything, okay? Basically, we are adding a double bond O to this carbon. This double bond is gone, okay? This reaction is broken. Again, as I said, we will learn more about this mechanism later. For now, all I want you to do is understand the reactions and possibly name them. So you draw everything up until this carbon and add a double bond O. Well, this is a terminal double bond O, so this is an aldehyde. Okay, and you do the same for the other one. Draw everything with the carbon and to the right of it, and then add a double bond O. Well, the double bond O is in the center of the chain, so that's a ketone. Okay, and I want you to name both of these. Again, naming is not the sole purpose of these videos. It's to drive the content. And in the process, I also want you to name both of the compounds. So if your reaction reagents are ozone and dimethyl sulfide, then you end up making an aldehyde and a ketone. Okay? Let's go to the second one. If your reaction contains ozone, but contains hydrogen peroxide, then you typically make either aldehyde or ketone and an acid. The acid is default. Aldehyde or ketone could vary, okay, depending on the molecule that's given. Okay, this is default. One of them will be for sure an acid. The other could be an aldehyde or ketone. Okay, now to determine that, first write the two carbons containing the double bond. This carbon contains a hydrogen. The carbon that contains the hydrogen, okay, will result in an acid. So basically, you write the carbon, okay, and then write, well, basically write what's there, and then add a double bond O and a OH. Yes, it's a little bit advanced, but remember, just write C and whatever's left off of it. Add a double bond O and OH. Now we have an acid. Rewrite the other one. The one that doesn't have a hydrogen results in a ketone. So write everybody, okay, and the carbon as well, and just add a double bond O. So the carbon that doesn't contain any hydrogen will turn into a ketone. So this will become a ketone. This will become an acid. We will look at another example later down the road where how we can make an aldehyde and a ketone, aldehyde and an acid. But for now, this is good enough. Okay. So let's do maybe one more example. Okay. So let's say I have this. Okay. What do you think are the products when I reacted with ozone and H2O and hydrogen peroxide? Well, I write my two carbons. This is a carbon that doesn't contain any hydrogen because it's already met 4. So this would more likely result in the formation of a ketone. This carbon contains 1 hydrogen. Let me actually write it this way. So this was the reactant. So this would lead to the formation of an acid, right? So that would be, so write everything up until the carbon and write a double bond O and a OH, because that's the carbon that contains the hydrogen, which leads to the formation of an acid. Plus, you write the carbon, the other one, and just write a double bond O, and this would be the ketone. And I want you to name both of these ones. Okay. Sorry, this is the acid. Name both compounds. Again, naming is a component of the exercise, but the sole purpose is actually you being able to recognize. So ozonolysis can lead to a formation of a ketone and an acid, or a ketone and an aldehyde. The first case, the DMS results in an aldehyde and a ketone, and typically an hydrogen peroxide results in the formation of a ketone and an acid. All right. This is ozonolysis, by the way. This is a special case. Okay. It's a very special case. So I'm going to keep this as a separate, and then we're going to continue our discussion on other chemical reactions.